Hello students, welcome to the next video of derivative. In today's video, we are going to see the derivative of one function with respect to another function. Okay, this concept is same as parametric function. Okay, in parametric function, what is given? It is given that differentiate or find dy upon dx if x is equal to a sin theta and y is equal to suppose b cos theta. Okay, then find dy upon dx. Okay, now this dy upon dx means we are differentiating y means b cos theta, right? We are differentiating y means b cos theta with respect to x means a sin theta, right? So in another word we can write this dy upon dx as differentiate y means b cos theta with respect to x means a sin theta, right? That is the other way of writing this part. Okay, if the question is find dy upon dx where y is a b cos theta and x is a sin theta, then we can say that differentiate b cos theta with respect to a sin theta. Okay, and this is known as a derivative of one function with respect to another function. Okay, so derivative of one function with respect to another function, this can be understood as the extension of parametric derivative, right, which we had already seen. Okay, so dy upon dx, that is equal to dy upon dx upon dz upon dx. Okay, so which we had already done in parametric derivative. Now let us see the example. So example 1 is differentiate tan inverse 4x with respect to e raised to 6x. Okay, differentiate tan inverse 4x with respect to e raised to 6x. Now here let y is equal to tan inverse 4x and z is equal to e raised to 6x. So we are interested in finding dy upon dz, right? So we are interested in finding dy upon dz, but here variable x is given, y and z both are given in terms of x, right? So it is nothing but a parametric function, both are given in terms of x only. Now let us differentiate y with respect to x. So dy upon dx. Now tan inverse x, derivative of tan inverse x is 1 upon 1 plus x square. So derivative of tan inverse 4x will be 1 upon 1 plus 4x square into derivative of 4x, and derivative of 4x is 4. So we'll get 4 upon 1 plus 16x square. Okay, now z is a e raised to 6x. Now we are going to differentiate this z with respect to x. So dz upon dx will be e raised to 6x into derivative of 6x. So 6. So finally we are interested in dy upon dz, right? Y upon z. So dy upon dz will be dy upon dx divided by dz upon dx, and dy upon dx is 4 upon 1 plus 16 x square, and dz upon dx is e raised to 6x into 6. Okay, so finally we get 2 upon 3 into e raised to 6x into 1 plus 16x square. Okay, so this is the required derivative. Now let us see one more example. Question is, differentiate log x raised to x with respect to 5 raised to 4x. Okay, so here y is equal to log x raised to x and z is equal to 5 raised to 4x. Now see this first term, that is log x raised to x, right? This function is function raised to function, right? Now function raised to function is given, therefore we have to apply the logarithmic differentiation, right? So for that we take log on both the side, so we get log y, that is equal to x into log of log x. Okay, now differentiating this with respect to x, so derivative of log y will be 1 upon y dy upon dx. Okay, that is equal to now x into log x. So x is u and log x is will be v. So apply u into v rule. So x into derivative of log x. Derivative of log x will be 1 upon log x into derivative of log x, and derivative of log x is 1 upon x plus log x into derivative of x, and derivative of x is 1. Okay, so x cancel. So finally what we get? We get 1 upon log x plus log x. Okay, here z is equal to 5 raised to 4x. So differentiating z with respect to x, so we get dz upon dx, and that is equal to 5 raised to 4x means a raised to x formula. So derivative of a raised to x is a raised to x into log a. So derivative of 5 raised to 4x will be 5 raised to 4x into log 5 into derivative of 4x, right? And derivative of 4x is 4. So finally we get 5 raised to 4x into log 5, right, into 4. Okay, then we get dy upon dz, that will be dy upon dx upon dz upon dx. So that is equal to log x whole raised to x, right, this y, into derivative into 1 upon log x plus log x whole divided by dz upon dx means 5 raised to 4x into log 5 into 4. Okay, and this is the required function, or required derivative. Okay, this is the derivative of given function. Now see some more example. So question is, differentiate tan inverse 2x upon 1 minus x square with respect to sin inverse 2x upon 1 plus x square. Okay, so here we take y as tan inverse 2x upon 1 minus x square and z as sin inverse 2x upon 1 plus x square. Okay, now here we substitute x as tan theta. Okay, when we substitute x as tan theta, then we get theta is equal to tan inverse x, and by substituting in y and z we get 2 tan theta upon 1 minus tan square theta, and this part 2 tan theta upon 1 minus tan square theta is a formula of tan 2 theta. Okay. So finally what I am getting? Tan inverse tan 2 theta. So tan inverse tan will be cancelled out and we get 2 theta. But theta is tan inverse x. So we get 2 into tan inverse x. Okay. Now we differentiate y with respect to x. So dy upon dx, that is equal to 2 into derivative of tan inverse x is 1 upon 1 plus x square. Okay. So finally we get dy upon dx as 2 into 1 upon 1 plus x square. Now we substitute x as tan theta in z. So we get sin inverse 2 tan theta upon 1 plus tan square theta. Okay. And this is nothing but formula of sin 2 theta. So we get sin inverse sin 2 theta. So sin inverse sin cancel out. So we get only 2 theta. Okay. But theta is sin inverse x. Theta is tan inverse x. So we get 2 into tan inverse x. Now we differentiate z with respect to x. So we get dz upon dx. So 2 into derivative of tan inverse x is 1 upon 1 plus x square. Okay. So 2 upon 1 plus x square. Okay. Now after getting dy upon dx and dz upon dx, next we have to find dy upon dz. Then this dy upon dz will be dy upon dx divided by dz upon dx. Okay. Now let us substitute dy upon dx. So dy upon dx is 2 upon 1 plus x square divided by dz is again 2 upon 1 plus x square. So terms will be cancelled out. So we get answer as 1. Okay. So dy upon dz is 1. See similar type of sum. Again the question is differentiate sin inverse 2x upon 1 plus x square with respect to cos inverse 1 minus x square upon 1 plus x square. Okay. Again inverse trigonometric function. So again we substitute x. Okay. When we substitute x as tan theta, then we get theta as tan inverse x. Okay. Then y will be sin inverse 2 tan theta upon 1 plus tan square theta, and which is nothing but the formula of sin 2 theta. Then sin inverse sin cancel out and we get y is equal to 2 theta, and by substituting this theta as tan inverse x, we get y as 2 tan inverse x. Okay. Then differentiating y with respect to x, we get dy upon dx, that is equal to 2 into derivative of tan inverse x is 1 upon 1 plus x square. Okay. Now after getting this dy upon dx, let us see z. So z is cos inverse 1 minus x square upon 1 plus x square. Again we substitute x as tan theta, right? So when x is tan theta, then 1 minus x square will be 1 minus tan square theta, and 1 plus x square will be 1 plus tan square theta. And this part is nothing but the formula of cos 2 theta. Okay. So we get cos inverse cos cancel out. So we get 2 theta only. But theta is tan inverse x. So finally we get 2 into tan inverse x. Now we differentiate z with respect to x. So hence we get dz upon dx, that is equal to 2 constant. Derivative of tan inverse x as 1 upon 1 plus x square. Okay. So we got dy upon dx. We got dz upon dx. Now we will find dy upon dz. which is dy upon dx divided by dz upon dx. Okay, so that means 2 upon 1 plus x square into 1 plus x square upon 2. Okay, or 2 upon 1 plus x square divided by again 2 upon 1 plus x square. So 2 cancel, 1 plus x square cancel. So we get dy upon dz as 1. Okay, this is the required derivative. Clear? So with this I am concluding my video. So thank you students. Have a good day.